Hello students, this is a video on the topic tests available for Quant on Bodhee Prep. These tests are designed to help you figure out whether you are ready with the concept for the exam or not. So once you cover the basic concepts of a topic, you take the test for that topic. With every test, there is a video which gives you the solutions and a basic analysis of how the test should have been attempted, the kind of difficulty level, and the time that should have been invested. There are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description below, so make sure you download the app and make the most of these tests. This video is on the topic polygons, and this is test number 1 that we're discussing. Overall, it was a moderate level of difficulty test, and 5 questions out of 8. There are 8 questions in this test, so 5 out of 8 would have been a pretty good attempt, a 95 plus percentile, and the time taken for this would be somewhere around the 16 to 17 minute mark. If we look at the questions, the first question says, let A and B be two regular polygons having A and B sides, respectively. B is twice of A, and each interior angle of B is 3/2 times each interior angle of A. Then each interior angle in degrees of a regular polygon with A plus B sides is. Now, if B is equal to 2 is given, each interior angle of B will be of measure 180 minus 360 upon B, number of sides, which is 2A. Each interior angle of polygon A will be 180 minus 360 upon A. It is given that each interior angle of B is 3/2 times. Therefore, we write the equation 180 minus 360 upon 2A is 3/2 times of 180 minus 360 upon A. So this becomes cross multiplying 360 minus 360 by A is equal to 3 into 180 minus 3 into 360 by A. So this goes here, 3 into 360 by A minus 360 by A is equal to 3 into 180, which is 540 minus 360. This becomes 2 into 360 by A is equal to 540 by 180. 182 is 360, so A comes out to 4, which means B is equal to 8. 2 times of 4. We have to find out the interior angle of a polygon which has A plus B, that is 12 sides. So with 12 sides, the interior angle, say X, will be 180 minus 360 by 12. 360 by 12 is 30, so 180 minus 30 or 150 degree becomes my answer. Again, there are 3 equations or 3 expressions that need to be solved, and therefore I'm saying moderate. Should take about 2 to 2.5 minutes to solve. ABCDEF is a regular hexagon with AB is 5, side is 5 centimeter. 9 line segments are drawn in the hexagon in such a way that AB, DE, and these lines form 11 equidistant parallel lines. If the ends of each of the line segments lie on the perimeter of the hexagon, then what is the sum of the lengths of the 9 segments? So this is our hexagon, a regular hexagon. There are 9 lines that are to be drawn. Obviously, one of them will be the center line, 4 on each side. They will be parallel to each other and equidistant. The hexagon that we have is A, B, C, D, E, F. So 9 lines and 2 A, B, and D, they are parallel and equidistant. We have to find the sum of these lines. What I'm doing is, I am joining, suppose, AC. Now in triangle ACB, we get this kind of a triangle which has 4 parallel lines. 1, 2, 3, 4. And therefore, and they're equidistant. So all of these will be, say, have a distance of A amongst the lines. Therefore, if this triangle is ACB and these points are 1, 2, 3, 4, 5, 6, 7, 8. Using similarity, we can say that the line 1, 5 will be the line 1, 5 upon AB will be nothing but A upon 5A. A upon 5A. 1, 2, 3, 4, 5. So it will be 1/5 of AB. So this line segment here will be 1. This line segment here will be 2 because it will be 2/5 of AB, similar triangles. This will be 3, this will be 4. AB is given as 5. On the flip side, in triangle AFC, similarly, we can say this will be 1. This will be 2. On the other side, we have a ratio with FC not AB. On the other side, if you look at the triangle, we will have triangle AFC. In triangle AFC also, there are 4 parallel lines. 1, 2, 3, 4. But the length of FC will be twice of AB because it is a longer diagonal. So this will be 10. So here, this line will be 1/5 of 10, which is 2. This line will be 2/5 of 10, which is 4. 3/5 of 10, which is 6. 4/5 of 10, which is 8. So the line segments here will be 2, 4, 6, 8, and then eventually 10. So if you look at the length of the lines, AB has length 5. The next, this is 4 plus 2, which is 6. This is 3 plus 4, which is 7. 6 plus 2, which is 8. 8 plus 1, which is 9. And then we have FC. On the right side of FC, we will have a similar series that will be formed. The first line will have length 8, then 7, then 6, and then we'll have DE5. So the sum of the 11 lines, we have to find the sum of the 9 line segments. So the sum of the 9 line segments will be in between here. 6, 7, 8, 6, 7, 8, 9. 6, 7, 8, 9. FC10 is missing. Yeah. We write this again. So if we look at the line segments, AB is 5, then we have 4 plus 1, 4 plus 2. 4 plus 2, 6, 3 plus 4, 7, 6 plus 2, 8, 8 plus 1, 9. Then we have FC10. 4 line segments here, 4 on the other side, which will be 9, 8, 7, 6. On either side of these, we'll have AB and D, which are 5 and 5. They are not to be counted. What is the sum of the length of the 9 line segments? So 6 plus 6 is 12, 7 plus 7 is 14, 8 plus 8 is 16, 9 plus 9 is 18 plus 10, 18 plus 12, 30, 14 plus 16, 30 plus 10. And therefore the sum becomes 70. Option C. Again, I will call this probably a moderate to difficult question. Similarity has been used and we'll have to break it into triangles as well. So the attempt time might be a little higher, maybe up to 2.5 minutes as well. A square whose side is 2 meters, square with side 2 meters, something like this, has its corners cut away to form an octagon with all sides equal. So here the corners are cut away and we'll get an octagon. All the sides are equal. This corner was cut away. So now we're making this dotted line. Similarly, here the corner was cut away. Therefore, we will have this line here. Similarly, this corner was cut away. Similarly, this corner was cut away. And therefore, the octagon that we have is A, B, C, D, E, F, G, H. All the sides are equal. The length of each side of the octagon is to be found out. Now, the side of the square was 2 meters. Also, we know that in an octagon, the angle here is 135 degree. This can be found out by 180 minus 360 by 8. It will be 180 minus 45, which is 135 degrees. Since this is a straight line, so this will be 135 minus 80, which is 45. This is 90 degrees, this will be 45 as well. So if for this length, suppose if we say this is P, if AP is X, AB also has to be X. And therefore in triangle APB, AB has to be root 2X. A right angle triangle with 2 sides X. the length of the sides of the octagon is same. So if AB is root 2x, this will also be root 2x. With similarity on these sides, we can say, because these are right angle triangles, same angles, and one of the sides is same. This length and this length is same. The angles are 45, 45 degrees, so congruent triangles, so this will be x as well. So along this line, say PQ, we can say PAX plus AH root 2x plus HQX will be the length of the square, that is 2. And therefore 2 plus root 2 into x will be equal to 2. Therefore x will come out to 2 upon 2 plus root 2. We have to find the length of the octagon, which is root 2x. And therefore root 2x will be 2 root 2 upon 2 plus root 2. Dividing everything by root 2, we'll get 2 upon root 2 plus 1. 2 upon root, option B is the answer. I think this is a question that you would have done earlier. Therefore, I'm saying easy, about 90 seconds to solve. ABCDEF is a regular hexagon. What is the ratio of the area of ACE, regular hexagon? What is the area ABCDEF? Area of triangle ACE, this part. So area of hexagon ABCD. Now ACE will be a equilateral triangle because AC, CE and AE are the smaller diagonals of a hexagon. From AE, three diagonals are possible: AC, AD, and AE. AC and AE are the smaller diagonals. AD will be the larger diagonal. The length of AC will be root 3 times of A, the distance between parallel sides. If A is the side of the hexagon, therefore we can say area of triangle ACE will be root 3 by 4 root 3 by 4 root 3 A square. The area of hexagon ABCDEF will be 6 into root 3 by 4 A square, because there are 6 triangles that are formed, equilateral triangles in a hexagon. We look at the area of each triangle as root 3 by 4 A square, multiply that by 6. This gets cancelled out, A square gets cancelled out. We get 3 square upon 6, root 3 square upon 6, which is 3 by 6, or 1 by 2 becomes my answer. Another way of doing this question would be, since we have a hexagon and we are looking at this triangle, if we simply join the vertices to the center, we can see that for each of the triangle in the hexagon, this line of the triangle ACE will divide the triangle of the hexagon into two equal parts, one inside AC, one outside AC. This will happen for each of the triangles, and therefore for each of the triangles, half of the area will be inside AC, half of the area will be outside AC, and therefore we can say the area inside AC will be the same as area outside AC. So AC upon total area will be 1 by 2. One part is inside, one part is outside, so the total ratio will be 1 upon 2. This or that. Either ways, I think easy question, not more than about a minute and a half to solve. In the figure given below, a regular hexagon has been constructed inside a rectangle. Find the ratio. Regular hexagon. Ratio of the area of the shaded region to that of the rectangle. Suppose the side of the hexagon is A. All of these sides become A. The interior angle of a hexagon is 120 degree. 180 minus 360 by 6. So this angle is 120, which means this angle will be 60. This is 90 degrees, so this will be 30. Now in a triangle which has angles 30, 60, 90, the ratio of sides is A, or rather x, root 3x and 2x. Here the hypotenuse is A. This length here will be A by 2. This length here will be root 3 A by 2. A by 2, root 3 A by 2, twice of A by 2, which is A. So this length here will also be A by 2, and this length will be root 3 A by 2. This length will also be root 3 A by 2. So if we look at the area of the shaded region, which is rectangle minus the hexagon, the area of the rectangle from here can be written as this side becomes root 3a by 2 plus root 3a by 2. The breadth is root 3a. Length is a plus a by 2 plus a by 2. So a by 2 plus a by 2 is a plus a is 2a. Therefore, 2 root 3a square. The area of the hexagon will be 6 into root 3 by 4a square, which is 3 root 3 by 2a square. And therefore, the shaded region will have the area of the rectangle to root 3a square minus 3 root 3 by 2a square. This will be 4 root 3 by 2a square. We have to find the ratio of the area of the shaded region to the rectangle. So the required ratio would be root 3 by 2 a square upon 2 root 3 a square. A square cancel, root 3 cancel, 2 goes to the denominator, 1 by 2 by 2 is 1 by 4, and therefore the required ratio is B. Required answer is option B, 1:4. Again, at best a moderate level of question, we just have to break it down into 30, 60, 90 triangle. From there, it would not take too much time. The figure below shows a regular octagon. Octagon has angle 180 minus 360 by 8, interior angle. 360 by 8 is for 135 degree. BAC is alpha, CAD is beta, DAE is gamma. We have to find the ratio of alpha, beta, gamma. Now, if we look at alpha, this angle here is 135. This side is equal to this side, so these two angles will be same. And therefore, we can say angle BAC, angles opposite equal side are equal. So angle BAC plus angle BCA plus 135 should be 180 in the triangle BAC. So angle BAC, BCA will also be equal to BAC. So let us write this as BAC as well. Is equal to 180 minus 35, which is 45. And therefore, twice of BAC is 45. Angle BAC or alpha is equal to 22.5. So this angle here, alpha, becomes 22.5. Next, we look at the trapezium ABCD. This angle here is 130. This angle here is 135. 135. That is 270. So the sum of these two angles here in the trapezium should be 180. So 360 minus 270, which is 110, which is 90. Also, by symmetry, we can say these two angles will be equal. Therefore, alpha plus beta should be 90 by 2, which is 45. This angle here plus this angle here is 90. So this will be 45. This will also be 45. By symmetry, it is clear. And therefore, since alpha is 22.5, we can say beta will also be 45 minus 22.5 or 45 minus alpha, which will again come out to 22.5. So an alpha and beta are the same. Next, we look at gamma. Now, if we look at this diagonal AE, AE divides the octagon into two equal halves. AH, HG, GF, FE, AE, AB, AC, CD, DE, AE. 1, 2, 3, 4 sides here, 1, 2, 3, 4 sides here. Therefore, this entire thing, alpha plus beta plus gamma, should be half of angle A. Angle A is 135, so 135 by 2, which will be 67.5. Alpha plus beta we know is 45. Therefore, gamma will be nothing but 67.5 minus 45, which will again give us 22.5. So all these three angles are equal, so the ratio will be 1:1:1. Option A becomes my answer. Because there is some level of calculation involved, we'll have to break down angles. So I'm saying moderate, but definitely a question that should be done in about 2 to 2.5 minutes. The number of equilateral triangles that can be formed by joining the vertices of an n-sided regular polygon is 9. Find the value of n. Now, if we draw a circle around the polygon and take one of the points on the polygon, vertices of the polygon, to have an equilateral triangle, there is exactly one possibility. From this point, from this vertex, there has to be another vertex at an angle of 120 degree. And from this vertex, there has to be another angle of 120 degree. So using one vertex, we can draw exactly one equilateral triangle. If from the other vertex I try to draw an equilateral triangle, again I will need 3 specifically separated points, which will be somewhere here. Sorry. And therefore what I'm saying is, or the general rule that we can use is, for an equilateral triangle, we need 3 points. These 3 points will form an equilateral triangle. Therefore, if it is an n-sided polygon, the number of equilateral triangles will be n by 3. So if equilateral triangles are 9, then the number of sides will simply be 9 into 3, 27. And that becomes my answer. As a matter of fact, if we have 3 vertices, 3-sided polygon, which is a triangle, there is exactly 1 equilateral triangle possible. If there is a hexagon, there are 2 equilateral triangles possible. In a hexagon, if I join these 3 vertices, or if we, sorry, in a hexagon, if we join these 3 vertices, we get an equilateral triangle, or if we join these 3 vertices, we get an equilateral triangle. So with 6-sided polygon, 2 equilateral triangles are possible, and therefore 27-sided polygon, 9 equilateral triangles are possible. 27 becomes my answer. But again, going forward, this rule can be used directly, but unless we know this rule, this would be a difficult question to solve. The area of a regular polygon is x units. The area of a regular polygon of side x units is 10x square units, and the length of n radius is an integer. How many such polygons would be there? So here what we do is, we know that the area of a polygon is nothing but in radius into semi-perimeter. Why this happens is because if there is a polygon, suppose I'm drawing a hexagon to be, and there is an incircle, we join the center of the vertices to the, we join the vertices to the center. Now, if we drop a perpendicular here, this is the in radius. The area of this triangle will be half. Area of the triangle will be half. This is the in radius, the perpendicular. So half into in radius into side. There will be n such triangles that are possible. So overall area of the polygon will be half into in radius into side into number of triangles, which will be for 1 triangle for each side. This can further be written as r into a into n by 2. A into n will be the overall perimeters. Every side of length n sides. So this becomes perimeter. Perimeter by 2 is semi-perimeter. So for any polygon, we can write area of the polygon is in radius into the semi-perimeter. Here, area of a regular polygon of side x is 10x. So area is 10x. Length of is and the length of the in radius is an integer. Semi-perimeter will be if the sides are n, so n into x by 2. X and x can get cancelled, and therefore r into n has to be 20. Now, because it is an integer, r could be 1, n could be 20, r could be 2, n could be 10. 3 is not divisible, r could be 4, n could be 5. R could be 5, n could be 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. R could be 10, n could be 2, but this is not possible because the number of sides of the polygon has to be 3 or more. So these 4 cases are possible. We could have a 20-side polygon with in radius 1, 10-sided polygon with in radius 2, 5-sided polygon with in radius 4, or a 4-sided polygon with in radius 5. Hence, 4 such polygons are possible. I will call this question also as probably a difficult question because all of us may not be comfortable with the formula of R into S. 2 to 2.5 minutes to solve. So if you look at the overall test, I'm saying a moderate test with about 16 to 17 minutes to solve and trying 5 questions out of 8. For me, my 5 questions will be 1, 3, 4, 5, 6. Which are these? Formula based easy calculation should be doing this one. Here may or may not strike, so not counting this one. This again have done similar questions earlier, so definitely counting. This is again something that I've done earlier, so counting this question as well. This I think was an easy question on the similar lines as the question number 3. Therefore, counting this again. We worked extensively with angles of octagon. Therefore, counting this question. Similar question was also asked in CAT back in the year. So, familiarity is there with this question. So, counting this again. This may not happen unless we have an idea of how to go about it. So, not counting it as a sure shot question. Similarly, here, everyone may not be comfortable. So, for me, my sure shot questions will be 1, 3, 4, 5, and 6.